Your model can score perfectly on its training data and still be lying to you. Last episode, we trained a line that fit the data. Today, a line that fits so well it starts memorizing noise instead of learning the pattern. That's overfitting, and it's one of the most common failures in real machine learning. The fix isn't a new algorithm. It's one small penalty bolted onto the cost function you already know. This is episode 6, Regularization, Ridge, Lasso, and ElasticNet. By the end, you'll watch one useless, random feature get caught and deleted automatically. Let's stop the lying. Here's the trap. More features usually means a better fitting line on your training data. Add enough features and the model can bend itself around every single point. Perfectly. That looks like success. It's actually the opposite. A model that memorizes your exact training points has learned coincidence, not pattern. Show it a new house it's never seen, and that perfect-looking model falls apart. That gap, great on training data, bad on new data, is overfitting in one sentence. The fix is almost embarrassingly simple. Tax big coefficients. Remember, the cost function from last episode, mean squared error, measuring how wrong the line is. Regularization adds one more term to that same cost. A penalty based on the size of every coefficient. Now the model can't just minimize error anymore, it has to minimize error and stay small. A feature has to actually earn a large coefficient by being genuinely useful. Useless features, random noise, they get pushed down because they're not worth the tax. First flavor, ridge regression, also called L2 regularization. Ridge's penalty is the square of every coefficient. Add it up. Squaring punishes big coefficients hard, but small ones barely at all. The result: every coefficient shrinks a little, together, smoothly. Nothing gets deleted. Ridge just turns everything down like a dimmer switch. Great when you believe most of your features matter, at least a little. Second flavor, Lasso regression, L1 regularization. Lasso's penalty is the absolute value of every coefficient, instead of the square. That one change in the math has a huge consequence. Lasso doesn't just shrink weak features, it can push them all the way to exactly 0. 0 means the model deletes that feature completely. It's not using it at all anymore. That's automatic feature selection, built directly into training for free. So which is better, smooth shrinking or deleting features outright? ElasticNet's answer: why not both? It blends the ridge penalty and the lasso penalty in one formula. One knob called L1_ratio controls the mix, all ridge, all lasso, or anywhere between. Especially useful when features are correlated with each other. Lasso alone can behave erratically there. ElasticNet is the safe, flexible default when you're not sure which penalty fits. Every one of these has a dial, alpha, how hard the penalty bites. Alpha at 0 means no penalty at all, you're back to plain linear regression. Crank alpha up, and coefficients get squeezed harder and harder towards 0. Too low, and you haven't fixed the overfitting. Too high, and the model underfits, too simple to be useful. Finding the right alpha is a tuning problem, usually solved with cross-validation, coming later in this series. In code, the switch from plain regression to regularized is almost nothing. From sklern.linear_model import ridge, lasso, ElasticNet. Ridge, alpha equals 1.0, fit, x, y. Same pattern you already know, one new parameter. One detail that matters a lot. Standardize your features first. If SQFT is in the thousands and bedrooms is a single digit, the penalty punishes them unfairly. Standardizing puts every feature on equal footing before the tax gets applied. Let's catch this in the act. I'm adding a completely random, meaningless number as a feature. It has nothing to do with house prices. Pure noise. Plain linear regression still gives it a non-zero coefficient. It's fitting to coincidence. Ridge shrinks that coefficient down, but doesn't kill it completely. Lasso drives it to exactly 0. Deleted. Gone. That's not a lucky run. That's the L1 penalty doing exactly what it's built to do. If you're building this channel with me, this is the kind of moment worth subscribing for. One small formula change, a completely different outcome. So ridge, lasso, or ElasticNet? Here's the practical answer. Suspect most features matter at least a little? Ridge. Suspect several features are dead weight and want them removed automatically? Lasso.
Not sure? Or your features are correlated with each other. ElasticNet, the safe default.
When in doubt in a real project, start with ElasticNet and tune from there. Let's lock in the mental model. Overfitting, a model that memorizes training data instead of learning the pattern.
Regularization, a penalty on big coefficients, added right into the cost function.
Ridge L2, shrinks everything smoothly, keeps every feature.
Lasso L1, can delete useless features completely, down to 0.
ElasticNet, a tunable blend of both.
If this clicked for you, hit subscribe now. Episode 7 builds directly on this.
Quick look at where this fits in the bigger picture. Episode 7 moves from predicting numbers to predicting categories. Logistic regression.
Spam or not spam? Yes or no? Your first real classifier.
Everything about the cost function and penalties you learned today carries straight over. Episode 7 is Logistic Regression Classification for Beginners. You'll build a spam classifier and meet the sigmoid function for the first time. Subscribe so you don't miss it.
Before you go, your challenge task for this episode.
Same 8 houses as last time, but now with 3 features. SQFT, bedrooms, and 1 planted fake, pure noise. Task 1. Fit plane linear regression on all 3. Check what coefficient it gives the noise. Task 2. Standardize the features, then fit Ridge, Lasso, and ElasticNet on the same data. Task 3. Figure out which model kills the noise feature to exactly 0. Hint. It's the one with the absolute value penalty, not the squared one.
Pause the video. Try it yourself first.
The full solution is in the GitHub repo. Post your coefficients in the comments. You just learned why models overfit and the exact fix professionals reach for. Ridge, Lasso, ElasticNet, 1 penalty term, 3 flavors, real control over your model. Episode 7 Logistic Regression. Classification for Beginners drops next. Subscribe. Comment which model caught the fake feature in your run.
I'm Majas. This is CodeToAGI. Let's build.